Welcome back to the SMD Radio Podcast. I'm your host, Craig Coleman, and today we have Phil Wilkin, the manager of our Research and Development Department right here at Signalysis. Our mission is to keep you informed about the latest industry developments, and today's topic is particularly interesting. Phil is here to offer an exclusive look into his recent experiences with LabView, a widely acclaimed graphical programming environment known for its versatility and user-friendliness. It's a vital tool in various industries, including here at Signalysis. Phil's deep insights into LabView are invaluable, and we're excited to have him on the show to discuss his recent experiences, discoveries, and challenges with this powerful platform. So without further ado, let's dive right in.
So yeah, I've been doing a lot of work in LabView lately for a couple customers, and big change there is back in, 21 or something like that, they added the concept of a data reference. And one thing that really helped is for the object-oriented programming concepts that were in there, it allows you to not follow the data flow model of LabView as closely now with classes. So the class, instead of having a structure as its member data, it now has a data reference. And so when you branch a class line in the flow, what you're doing is you're copying that data reference, and in the past you'd actually be making a copy of the data. So if you modified it in one line of the flow, it wouldn't modify it in the other line of flow. Just really was hard to work with classes. And so an external group took the data reference stuff and they called it GOOP, G, Object-Oriented Programming. And they started using the data reference as the main member data. And so it's made the classes a lot more similar to what you'd get in Visual Basic.NET or C, where the flow model isn't quite as critical. So it's helped out quite a bit and made, in my opinion, the classes a lot more useful in LabView. So I've been using that on a couple different projects, and since in my career, I've written in probably, 20 or so scripted languages. To have to switch back between the flow model of LabView and some of the other models in the other languages, it's always been difficult. So it's kind of nice to unfortunately break the flow model of LabView, because that's what they've based their entire structure on. But it really helps me as a programmer to be able to switch back and forth without having quite as much of an issue.
Can you tell us how this process is being applied at Signalysis?
So, for example, in one of the projects, I've got a hardware-based class, and it's actually what's called a singleton, which is a type of class where there's only ever going to be one instance of that class. And in the past, I believe that's been difficult to do in LabView because of not having the ability to use the data reference. So the singleton allows me to have one hardware master class, and then he's kind of managing all the different pieces of hardware. So anywhere in a LabView program, I can drop that class icon. So again, it breaks the flow model because there's no wire coming in and going out. But I can drop that icon and get access to any of the hardware that's being used in the system, at which point from there I can ask it, for instance, give me the signal conditioner class, a dev co-signal conditioner with this name, and it'll pop that out. I can work with that class, and again, I don't have to follow the flow. I can do what I need to do. I don't have to pass that wire on down through all the subclasses and everything else. It can just, I can get access to it. So again, makes it a lot more like what I'd be used to in C++, where you just get an instance of that object or a pointer to that, and you can work with it. So yeah, it's helped out to clean up the code quite a bit, because it used to be you'd have wires for all the different pieces of hardware running around, and you'd have to maintain those and make sure if you split them and changed anything on them that you merge that back in.
Roughly how much time are you saving with this approach? Is it something you can measure in terms of hours or days, or what's that equate to?
It's a tough one to actually put a metric on, I think, because object-oriented programming in general probably costs you a little more time up front in the development and design. But when it comes to debugging down the road and reuse of the code, that's where you get a lot of your time savings. So yeah, I've always kind of shied away from it in LabView using classes and things. But now, I've got this EndeavGo signal conditioner class. I'll be able to take that class into the next project that needs it and know that I don't really have to debug it because that class with all the methods to operate on the signal conditioner was debugged in the last project. So it saves you time in those areas, but sometimes it's a little more upfront design and coding.
So Phil, just want to get your observation on something. With ChatGPT and some AI, where do you see all that fitting in to the programming and debugging of software?
I haven't played or found whether any of those can actually work with LabView since it's a graphical programming language. I imagine that would throw kind of a wrench
or just in
the
general.
whole AI.
It doesn't have to be LabView, but just.
But yeah, I've not personally played with it, but one of our previous employees was here and he was talking about how he threw a couple definitions of functions that he wanted and it turned back some reasonably decent code. So in that aspect, I think a lot of, and it'll get more and more complex as time goes on, but right now it looks like, if you're starting from scratch, you can probably get a lot of functions that have been written kind of in the past. But if your company already has quite a bit of libraries and code that already exists, then by all means, you'll probably pull from there first because it's probably debugged and working well. And so yeah, I haven't played enough with it to know, but I imagine it'll change things for sure.
I have messed with it a little bit just because all these things like I'm interested in. I don't know anything about anything, but with ChatGPT, I asked it to write me a Python script, but I had to be more descriptive. Like I had to tell it I want a button. When you push that button, I want it to change colors, and I want the name of it to change. And I asked it. There's a couple of them. I've written quite a few of them, but like only a few of them work. But it did it. Like I've actually created some small little tiny Python apps that I know nothing about Python scripting, but AI did it for me.
Yeah, right now I think it's good for the function kind of concept, but the whole design of an architecture of a program for reuse and things like that, I think it'll take it a while before it learns how to do all that kind of stuff.
Someday. They'll take over.
So yeah, maybe able to get rid of the low-level programmers, but yeah, I think your architects and things are still going to be important for another couple years.
Yeah. All right. I think that about wraps it up. As we conclude, I'd like to express my sincere gratitude to our guest, Phil Wilkin, and my co-host, Bob Farrell, for their valuable input today. And to all of our listeners, thank you for joining us. Please remember to subscribe, like, and share this episode and others like it. Until next time, keep exploring, keep innovating, and stay tuned to the SMD Radio Podcast.